So moving on to the next one, we have f of x is equal to the square root of minus 2x plus 7. So now once again, we are dealing with the square root. So when we deal with the square root, as I mentioned earlier, we have to focus on the argument of that square root. And the argument of the square root is minus 2x plus 7. Now once again, this has to be non-negative or greater than or equal to 0. Right, so we subtract 7 from both sides. We get minus 7, and we divide both sides by minus 2. Now, when we're dividing both sides of an inequality by a negative number, then the inequality symbol, it flips. So we have this. So this gives us x, which is less than or equal to 7 by 2. Right. So the domain for this function will be x belongs to the interval from minus infinity all the way up to 7 by 2, and 7 by 2 is included. So we use a box bracket or a square bracket. So that's our domain. And if we were to find the range, well, for the range we can intuitively see that since the argument, so this is our argument, since the argument is always non-negative, then if we take this positive square root of a non-negative argument, then our result will also be something that is positive. That means the output will always be positive or non-negative too. So, for example, if we take the positive square root of 4, we will get 2, right? If we take the negative square root of 4, then we will have minus 2. So in this case, we don't have a negative sign in front of the square root, we just have a plus sign, right? So in this case, we will have positive outputs always, since the argument is always non-negative. Sorry, we will always have non-negative outputs. So the output will always be non-negative. So f of x will be always greater than or equal to 0. Now also, once again, we can show this explicitly by letting y is equal to f of x equals to square root of minus 2x plus 7. Now we can solve this equation for x. So we square both sides so we can get rid of this square root. So we have y squared is equal to minus 2x plus 7, and then 2x is equal to 7 minus y squared. Divide both sides by 2, so we get x is equal to 7 minus y squared by 2. So this is our expression of x, right? So now we can substitute this value of x into our original function. So f of x is equal to f of 7 minus y squared divided by 2 is equal to square root of minus 2x, but x is 7 minus y squared by 2 plus 7. Now our 2's cancel out, and we have a negative sign here and a negative sign here. So negative, negative, we get a positive y squared minus 7 plus 7, and this gives us the positive square root of y squared. So once again, we're taking the positive square root of y squared. So this is equal to y, meaning y has to be greater than or equal to 0. Y has to be non-negative since we're taking the positive square root, right? So in this case, y has to be non-negative. And so our range of this function is going to be from 0 to the positive infinity. So this will be our range. Right, and for the final function, we have g of t is equal to 2t over t minus 1. Right, so once again, the only restriction is that the denominator cannot be equal to 0. Right, so for the domain, t cannot be equal to 1. So for the domain of this function, t belongs to the interval where we have from minus infinity to 1 union 1 to positive infinity. So once again, we can have any value of t within this interval but excluding 1, or within this interval and once again excluding 1. Or we can write this as t belongs to the set of all real numbers except when t is equal to 1. And for our range, once again, we let y to be equal to 2t over t minus 1, and we solve this equation for t. So we multiply both sides by t minus 1. So we have y times t minus 1 is equal to 2t. We expand this to get yt minus y is equal to 2t. Bring the t's to the same side, and then we can factorize out the t to get y minus 2 is equal to y. And so, dividing both sides by y minus 2, we have y over y minus 2. So this is our expression for t. This is our equation for t. And we can see from the denominator that y cannot be equal to 2. Right? So our range for this function is y belongs to the set of all real numbers except for 2. Or y belongs is an element of the intervals from minus infinity to 2, but 2 not included. Union, we have 2, positive infinity. So that's the range of that function. Now, let's take a look at another function. So let's say we have p of x is equal to 2 square root of x plus 3. And the domain for this function is already given. Okay, let's say the domain for this function is ranging from less than or equal to 5 but greater than or equal to, less than or equal to 9 but greater than or equal to 4. So in this set, all of the elements are ranging from 4 to 9, but 4 and 9 included. So we have 4, 5, 6, 7, 8, 9. So how do we find the range for this? So what we can do is we can just manipulate this inequality, right? So we can just multiply this inequality. We can first square root this inequality and then multiply it by 2 and then add 3 so that the middle part resembles the function itself. So first of all, we take the square root on all sides. So we take the square root, giving us 2 square root of x. We get 3. And then we multiply it by 2. So we get 4 less than or equal to 2 times square root of x less than or equal to 6. And all we have to do is then add 3. So 4 plus 3, we have 7. 2 square root of x plus 3 and 9. Alright, so we can see that this middle portion is just now the exact same as the function itself, right? So we can say that 7 less than or equal to p of x less than or equal to 9. So this is our range. So p of x ranges from 7 to 9. So we can say that p of x belongs to the interval 7 all the way to 9. And once again, we use the square brackets because 7 and 9 are part of the range. So this is our range. Let's take a look at two more functions. And we have f of t is equal to 2t minus 4 over 1 by t minus 1 over 3t minus 4. Right? So we have these two functions. They look a bit complicated, but it's actually not that hard. So if we find the domain, all we want to do is find the domain of these functions. Right? So for the first function, we can see for this function that there is a square root. So that means the argument has to be greater than or equal to 0. It has to be non-negative. And that means x has to be greater than or equal to 5 by 2. Right? And also, we can look at the denominator and see that x minus 3 cannot be equal to 0. And that means x also cannot be equal to 3. Right? So we have these exceptions that we have to exclude from the domain. So for this, the domain is x belongs to a set of all real numbers with the exception of 5 by 2. Actually, no, this is wrong. We have to use interval notation to show this. So x belongs to, or x is an element of the intervals from 5 by 2 up to 3, and then from 3 to positive infinity. So this is just the union of these two intervals. So x can be an element from 5 by 2 up to 3, but not including 3, and then from 3 to positive infinity, but not including 3. And we use this square bracket because 2.5 or 5 by 2 is included. And for our next function, so we have several rational expressions in our denominator, right? So first of all, we have 1 by 2, and we have 1 by 3t minus 4. So just from these rational expressions, we can see that the denominators cannot be equal to 0. Right, so t in this case cannot be equal to 0, and in this case 3t minus 4 cannot be equal to 0. That means t cannot be equal to 4 by 3. And on top of this, the entire expression also cannot be equal to 0. So we have 1 by t minus 1 by 3t minus 4. This whole expression cannot be equal to So what did we have? We had 1 by t minus 1 over 3t minus 4. This cannot be equal to 0. So all we do is equate the two different sides to find the values of t for when this is equal to 0. And we have, so 1 over 3t minus 4. We multiply both sides by t, multiply both sides by t 3t minus 4. And so we have 3t minus 4 is equal to t. Right, so we bring the t on the same side. So if 3t minus t is equal to 4, we have 2t is equal to 4. Divide both sides by 2, and so we have t is equal to 2. So t is equal to 2 when this is equal to 0, right? So we cannot have this. We have to exclude t is equal to 2, and from the previous notes we showed that t cannot also be equal to 0 or 4 by 3. So we have to exclude all of these values of t from the domain, right? So our domain for the function is x belongs to set of all real numbers except for 0, 4 by 3, or 2. Or you could write this in a much more complicated way with the interval notation by showing that x is an element of the intervals from minus infinity to 0. We have a union from 0 to 4 by 3, and then from 2 to the positive infinity. So 0, 4 by 3, and 2, these are not included, and which is why we used these parentheses. So this is our domain for the function f of x is equal to f of t is equal to 2t minus 4 over 1 by t minus 1 over 3t minus 4. Right. Now, for the very final question or example, we have, let's say we have this expression x squared minus x over x minus 1, and we can simplify this by factorizing an x out to get x times x minus 1 over x minus 1, and we can easily cancel out the x minus 1 terms from the numerator and the denominator to give x, right? So now let's consider some function of f of x, which is equal to x squared minus x over x minus 1. And we have another function g of x, which is equal to x. Now the question is, are these functions the exact same? Are these two functions equivalent? Well, if we want to find out if these two functions are equivalent, we can just take a look at their domain, right? So the domain of f of x, so the domain of f of x is what? So we can see from the denominator, x cannot be equal to 1, right? But for the domain of g of x, we can see that there are no restrictions for this. We can have any value of x from the set of all real numbers, right? For g of x, the domain is an element from the set of all real numbers. There are no restrictions for this. But for the case of f of x, x cannot be equal to 1, because if x is equal to 1, then f of x is undefined, right? So the domain of these two functions are clearly different. So these two functions cannot be equivalent. Now f of x is equal to x squared minus x over x minus 1. This can be simplified into x, as we showed over here. But that is only valid if x cannot be equal to 1. Right, so this simplification is only valid if x is not equal to 1. So since x is equal to 1 is a valid input in the domain of g of x, but not for f of x, these two functions are not the same. They're not equivalent. Now, if we have some function f and some function g, then from their sum, product, or quotient, we can generate a new function, right? So if we take the sum of these two functions, for example, let's say we have f plus g, then this gives us a new function. As long as f and g are defined, then h is also defined. Similarly, we can take the product of the two functions. Say we have the function t is equal to f times g, right? So by the product of these two functions, we can come up with a new function, and this t function is defined if f and g are individually defined as well. Similarly, we can have a function where we can take the quotient of these two functions, given that g cannot be equal to 0. And once again, f and g, they have to be defined for this function to be defined. Right. Now, similarly, we can also, with these functions f of x and g of x, we can also take the linear combination to generate a new function. So let's say h of x is equal to a times f of x plus b times g of x, right? So we're taking the linear combination of these two functions by multiplying these functions with some constant a and b, and then taking their sum. And that gives us a new function, h of x. So we can easily generate a new function by taking the linear combination of two other functions, given that these two functions are defined. Right, so that's all for the introduction of functions. In the next class, we will take a look at how to graph some of the functions that we have covered in this class.